going to be talking about the Lunar Mapping and Modeling Portal, and just as a little bit of an advertisement, he and the JPL team that are working on this, doing the technical work on this, are located just across the hallway from this conference room. I encourage everyone to come check it out. It's pretty cool.
Thank you very much, Greg, and thank all of you. I'm here to report that it is not your father's LMMP anymore. The Lunar Mapping and Modeling Portal has progressed. It started out as a mission planning tool for the Constellation program. Well, Constellation is now long gone, but the mission planning heritage of LMMP lives on. We're still doing mission planning, but it is now expanded to planetary science and some pretty significant public outreach. LMMP has also grown from being a strictly lunar product. It is now expanded to other worlds. We have a portal for Vesta and for Mars, and the technology for LMMP has been ported over to Earth Sciences projects too. There are a variety of user interfaces now beyond just the web interface that we started out with. You'll see a lot more of that. And one of the things that we are doing is serving our data out to a number of external platforms, including planetariums. Our stakeholders are the Advanced Exploration Systems Division of HEOMD, and Betty Siegel is our program executive there, and the Planetary Sciences Division of the Science Mission Directorate, and Kristen Erickson is leading us there. We've had a busy year. This year we did release our 2 new planetary portals. We released Vesta Trek at the end of March, and our new Mars portal was just released this month. So we really look forward to showing it off to you. Our most mature portal is our Lunar portal, LMMP, the Lunar Mapping and Modeling Portal. It is rich in analysis tools, allowing you to do lighting analysis, slope, hazards, profiles, sun angles. You can browse, search, download, and visualize data from many different instruments, from many different spacecraft, layering that information on top of each other, adjusting the transparency to really mine the data that you are specifically looking for. It is rich in collaboration tools, allowing you to have data that is specific to a team or you can share to the world. It has very easy ways for you to create electronic bookmarks. So once you have arranged a stack of data and adjusted everything to just bring out what you're looking for, you can save that and send that very easily to your colleagues, and they can view it very simply. We have a growing number of users, including Resource Prospector, the lunar science community. We're gaining international interest now, and yes, we're working with Google Lunar X Prize, and a growing list of people in the EPO arena. We have a bunch of new data products that we're bringing in. A lot of these are polar-centric. You remember we started out as constellation-based, and so a lot of those were more equatorial, but now we're getting a lot of good polar data in, including the 10 meter per pixel DAMs from LOLA, slope maps, roughness maps, permanently shadowed regions. From Diviner, we've significantly upgraded our Christensen feature composition map. It's a big improvement over what we were showing off here last year. We have thermal map, rock abundance map. Something we're really excited about is Wes Patterson at APL, who took over the reins from Ben Bussey, provided us with some mini RF data. It was pre-publication. This is the North Polar mosaic, including circular polarization ratios, the first Stokes parameter. And again, this is pre-publication information that is available for us to use for Resource Prospector mission planning and analysis. As soon as that publication is out, then that will become available for anyone to use. We've got a lot of exciting things in the pipe. One thing we're really excited about is the merging of the Lola and Kaguya terrain camera stereo DEM. I'll show you an example of that. It's very exciting. We're working with Sam Lawrence at Arizona State University in enhancing our NAC coverage. We are very much looking forward to the release of the re-registered M-cubed data from Chandrayaan, and we will be ingesting that. Just as we have the North Polar Mini RF mosaic, the South Polar is in works now, and we will be grabbing that as soon as it is available. There's a whole bunch of stuff from LAMP that we have our eyes on. A number of products are being developed here by Resource Prospector, and we are ingesting them. We'll show you some examples of that. In addition, we have produced a DEM for Resource Prospector of the Perry region, the North Pole of the Moon. We are on the hook to produce another DEM for them. That will be of an area to be determined, so Resource Prospector will let us know what area they would like, and we will produce that. Bill Farrell here and his survey team, we're working with them on a very exciting project, ingesting his algorithm for surface potential analysis. So this will turn into something very similar to our lighting analysis tool. You'll be able to put in a range of dates, also be able to put in some parameters for solar activity, and generate an animation of surface potential. We're also working with Survey PI David Kring in integrating his atlas of sinuous rills on the moon. We're going to be having enhanced tool sets, including hazard analysis and crater analysis and a new path tool. And we're working with the Astromaterials office at JSC to integrate their database of lunar samples. So when you get a moon rock, you'll be able to take that moon rock and, based on its catalog number, enter that into LMMP and see the contextual area from which it was retrieved. So this is an example here of the merging I was telling you about. So that's Lola. Now here's the merged with the terrain camera, and that's a WAC mosaic. A wax stereo DEM. So you can see that in terms of the quality of the digital elevation model, this new merger of Lola with the terrain camera stereo mosaic is really, really exciting. Moving on to Vesta. So we released in March our new portal, Vesta Trek. Unlike our other portals, this is based on a single spacecraft because, well, we've only had one spacecraft that's gone there. But it does have, again, a number of layers of data. It allows you to, again, stack these layers. It does have a much improved HTML5 based interface that provides for better 3D visualization and better navigation. We look forward to showing that off to you. Here's an example. You can see the ability to pull up different layers. Here we've got the 3D view of Vesta showing hydrogen abundance. Here's a close-up view of the pitted terrain just north of Marcia Crater. And then what we're going to do is we're going to overlay on top of this our mineralogy ratio. And you can see, and then again, adjust the transparency so you can see both the mineral ratio and the underlying morphology. And that's really kind of an interesting image right there. I like this. Looking at that pitted terrain and looking at the difference that is exhibited in the mineral ratio. Mars Trek is our newest product. We just released it at the beginning of this month. Again, it has a suite of analysis tools. It currently features detailed information on a number of landing sites, including the Mars Exploration Rovers, MSL, Phoenix, Pathfinder. We will be adding Viking landing sites to that list. Again, you can layer visualizations of numerous data sets. The flyover, the 3D flyover is spectacular. Data is coming from MRO, Mars Odyssey, Mars Global Surveyor, Viking, and we have been working with the PI of the HRSC camera on Mars Express. We'll be having that data very soon. In fact, it's being ingested, I think, as we speak. So the thing that I'm really enjoying about Mars Trek is just the incredible visualizations that you can do. So here is MOLA visualization of MOLA data of Valles Marineris. We drop down another view of Valles Marineris using daytime infrared Themis data. Here we have the Casey Valles area, again, MOLA imagery. Here we have the Columbia Hills, and a kind of a vantage that you rarely see. And Mars Trek has drawn the path of the Spirit rover there for us in green. And you can zoom in quite a bit closer than this, but I think it's really interesting to see the context of the Columbia Hills here. Here's Victoria Crater, and once again you have the path of the Opportunity rover shown in green. And you can drop right down on the ground, right next to it. This looks like an image taken by the rover. It's not. This was taken from orbit. But again, we can do visualization of this, in this case, high-rise orbital data to really put you on the ground where you need to be. Here's a flyover Mount Sharp in Gale Crater. Sitting on the ground next to the Curiosity rover, looking up at Mount Sharp. These are all using our web portal, but we have additional interfaces. We've been talking with Hyperwalls. We have mobile apps. We have our touch table that if you have not played with our touch table before, please come across the way and check it out. It is really amazing. And we also now have a prototype of our new 3D goggle interface. So this is the Oculus Rift goggles. And we've had a great deal of fun recently showing those off on Capitol Hill. And Emily put Charlie Bolden in the goggles. It was really quite an interesting photo op. But also very important here, you know, we have these different interfaces, but the real commodity here is our data. And so there are back-end services and APIs that are able to provide this data to external platforms. And that's a very important thing of what we're doing. Here's an example of one of the cool things is that on any of our portals, you can draw a box and you can use that to create 3D prints. And so we've got a bunch of those over there for you to see. Going forward, we're looking at other planetary bodies. Actually, headquarters is directing us to look at every other planetary bodies. Jim Green has instructed us to prepare to help out on Mars 2020 and human landing site candidates on Mars. Lunar Mission 1 has been talking about using LMMP. We're expanding a number of collaborations, international space agencies, again, working with our survey PIs. We're part of the SMD education infrastructure and working with planetariums. We've got the Hayden and Cal Academy are receiving our data, and Cal Academy is training other planetariums on how to ingest our data. And the software and capabilities that are developed for this are being used in many other areas. To wrap up, I want to again invite you to come across the hall, see our exhibit, play with our toys. It's a lot of fun. And I want to also call out the wonderful, amazing development team from JPL. We have a number of the representatives here today for you to talk with. And we've got some summer students coming here too that we are very, very proud of. Thank you very much.
Could I also ask Emily to stand up, Emily Law? Emily has been the lead of the JPL team, and I'd like to give her a hand as well. we were given a challenge less than 2 years ago now by HEOMD to take over management of this project after Constellation was canceled, and it was a pretty significant revectoring, you might say. And I'm just amazed at what both Brian and the JPL team has done to respond to it. I also want to emphasize that we, Survey, are doing this for you, the scientific community and the mission community. And so if you see things, if you have ideas on additional features that might not exist yet, please let Emily or Brian or any of the other JPL team that are here know. We want to respond to all of you. We want to make this the best product possible. Yeah, so are there any questions for Brian? Or do you want to just get across the hall and just play with it? It's really cool. Please.
Yes.
Good afternoon, Mike Broom. You mentioned data was your big commodity. Just speaking specifically about the moon, what's next for data collection? Where would they go? What robotically for data collection? Where would they go on the moon? What sort of data would?
Oh, so what kind of data are we looking for? So right now, what I should point out, so we are able to get data from the planetary data system, and we're able to provide perhaps a friendlier way for you to get that data, for you to actually download that data. But yes, we're looking at additional data coming in. There are additional data products coming from LRO, but then there's also, of course, a number of missions in the works right now. We have some very interesting small sat missions that are being discussed. You'll hear a number of things here today, and of course, as we are giving to Lunar Prospect or to the Resource Prospector, we are also hoping to receive from Resource Prospector. So, looking at sources ahead, as we continue going to the moon, as we continue robotic exploration, we will be gathering everything we can. And that includes from our international partners. So we're talking very closely with our friends at CARI, for instance. But for now, what I was specifically referring to as data as our commodity is this rich store of data that is in the PDS and that is accessible to you, because not only are you able to visualize it with LMMP, you're able to actually download that data. And it may be in a very compressed format when it's displayed, but you can get the full fidelity of that data as it comes down.
Thank you.
Time for one brief question. Go ahead,
I'll make
Brad.
it brief.
Oh,
Brian, Brad Bailey, Survey. Quick question. You mentioned EPO several times, and I was curious if you could highlight a few examples of how LMMP could really be used for EPO, and moreover, perhaps how citizen science could enhance LMMP as a whole.
Yes, actually, I'm involved with the Citizen Science Forum and just gave a presentation of this to that forum. There are a number of potential opportunities for using LMMP in citizen science. One great example is what our previous speaker was talking about here, David. I don't know if we want to go into detail, David, but one of the possibilities they're looking at is using LMMP as a site selection and analysis tool for the public, for their community. So they have this community that crowd-funded them. And now that community can actually get involved in making the decision, where is Lunar Mission 1 going to go? And we can give them the tools to do that. Within EPO, in a more formal setting, we've been made essentially a shared resource by the SMD EPO office, so we're not part of the CAN. For us, that's a very good thing, of the SMD EPO CAN. So we're external to that, but we're a resource for anyone that does win that CAN. So there are a lot of opportunities there. Thank you very much.
Yeah, thank you.